big problem that I face myself and clearly many others in the voice AI development space is the inaccuracy of extracting emails from conversations. Now, this is a pretty big problem for many reasons. The first being that extracting an email address is a binary. You either get it right or wrong. Being close or almost getting it does not matter. The second problem is a lot of genuinely interesting and valuable use cases of AI voice agents need the use of an email address, like booking appointments and reservations, or using the email as the lookup to the database or CRM. So over the past week, I've ran many different tests and experiments in order to find ways to improve the accuracy of email extraction in AI conversations. And through these experiments and tests, I was actually able to achieve an accuracy of 99% in both outbound and inbound use cases. And in today's video, I'm going to show you everything I learned through these experiments, as well as everything I did in order to, increase and get that level of accuracy. Okay, so I'll start off by talking about outbound, as this was the first thing I did in my experiments. And actually, it was a little bit easier in my experience to improve the accuracy. So to start my first test / experiment, what I wanted to do actually was get real world calls from, systems and agents that I had deployed for, my clients, and find calls where, an email address had been talking about in the transcript. Essentially, yeah, a call where an email address had been spoken about. Then I could use those calls and the call recording as well as the transcript in order to extract the email address as my test data. Now, I think the first place that I was thinking about, and probably most of you would do too, when you are, trying to test and, experiment with the accuracy of email extraction, was testing different LLMs. So that's exactly what I did. I basically wanted to find out if there are some LLMs that for some reason are just way better at extracting emails from a transcript, based on their intelligence, based on their training data. And I also wanted to just test, the difference between thinking models like R1, O1, the new Claude 3.7 Sonnet, and our regular quick LLM models. So for this test, what I did was I ran each LLM 50 times per unique call. So if my test data set of outbound calls was 10 calls, I would be running each LLM 500 times, and I would do that for every single one of my LLMs. And through that, I got this kind of accuracy. As you can see here, I have this table which shows you under simple accuracy what we were getting. So Gemini 2.0 Flash 4.0, Qwen Max, DeepSeek V3, and O3 Mini were all pretty much the same at around 40% accuracy. Now, as you can see at the top, there is simple accuracy versus complex accuracy. So the way I've kind of structured this is simple is just like, pure basic prompts like anyone would. What is the accuracy we are achieving? And then complex accuracy is after all the different tweaks and improvements I did, what kind of accuracy were we able to achieve? So just kind of as a spoiler, with the complex accuracy, as you can see, I was able to achieve 100% on Gemini 2.0 Flash, 78% on GPT-4o, and actually with a bit of more tweaking, which I'll explain in a second, on complex accuracy and Nova 3, we were able to average much higher. So in the top, 5 models, we're averaging maybe say 89 to 90% accuracy. So for the simple prompt, this is what it looked like. In this scenario right here, we just literally grabbed the outbound call and the transcript in the calls, sent it through this simple prompt, which was told, to extract the email address from the provided transcript. Do not add any other comments. Make sure it's formatted as a JSON object. And, I also, made the output format a JSON object. And with that, we got that 40% accuracy, as you can see in the data. Now, QuenMax did the best by just a little bit, which my assumption is, some of the responses that it was doing were better here and there. As you can see, these are all tied. So my assumption is they all kind of failed in the same like test data set. So anyway, so that was with the simple prompt, extremely, extremely simple. And as you can see with the complex accuracy, we were able to really, really, really improve that overall accuracy with our top 4 or 5 models. Now, for the complex outbound prompt, it looked a bit different. I told it that, it shouldn't just take the emails in the transcript as, gospel. It should think about the context of what is common in the industry. So I also, because all my data sets came from the same industry, I gave it some pointers like, often these types of professional companies have their company name as their domain. So, if someone from Google is calling, they might be john@google.com, right? Because they are using that professional domain in their, or their professional company name in their domain. I also told it that all the transcripts provided are from outbound calls. Be wary that sometimes what is written in the transcript could be incorrect. Properly analyze the call to figure out what the email could be. And I said I would put slightly more weight on the context provided in your instructions than on what the transcript says. And as you can see here, we have the context company name. Now, because these were outbound calls, these calls were being triggered based on certain things. And within our trigger, we have the company name object, right? So we are able to give that context to the LLM that is extracting the emails from the transcripts, and it can choose when or when not to use that company name in the extraction of the email. So for some of my examples, the company name was in the email. So let's say it was john@netflix.com, but imagine the transcript spelt Netflix completely wrong. So it actually spelt Netflix like that. I mean, it wouldn't in reality, but obviously these company names were a bit more obscure than Netflix. So let's say in the transcript it said Netflix like that. And so originally, with the simple accuracy, it would have done john@netflix.com like this, which is just incorrect. But because we gave it the company name, i.e., in here it would have said Netflix down at the bottom, it was able to realize, okay, so that change in spelling was likely to do with how the transcription, spelt it, and we can assume that the domain name or that the email looks more like that. But also in my transcript and the data and the test data, there was some emails that didn't use the company name in the domain at all. It just used a simple Gmail or Outlook, or it had a different way of spelling the company name in terms of, not the full company name, but just parts of it, or like netflixlimited.com, those types of things. So it actually, this prompt was able to, and these, more intelligent models like Gemini 2.0 Flash and DeepSeek R1 were able to realize, okay, so this is when I want to use the company name in the domain. This makes sense. And also other times when it didn't make sense. So that's how I improved the outbound, which was extremely simple. I mean, not only was I able to improve the outbound by using different models, right? Like O3 Mini gives me 37.6% accuracy. Like that is just terrible. And, I could use the better models like Gemini 2.0 Flash or DeepSeek R1 with that improved prompt and, the little improvement as well, or not so little, from Nova 3 and Retail. So by Nova 3, what I did was I grabbed those real world calls, grabbed the recordings, retranscribed them in Nova 3 specifically because as I was doing these tests, the new DeepGram Nova 3 model came out and I wanted to see, what the difference would look like for that. And as you can see, it does really improve the overall average accuracy. So next, what I want to talk about is inbound. Now, inbound is a little bit more difficult because we don't have that company name that I was able to use in order to, help improve the overall understanding of what the email should look like and what the email should be after extraction. Now, there is one thing that I thought, can be a big difference with inbound, and, it's because I saw better results with Retail and Nova 3, the next thing I naturally wanted to do was just to test different transcription models. Because for inbound, let's say we're on a conversation and someone says, I want to book a table for 7 p.m. We check the availability. There is availability for booking a table at 7 p.m. We get their email, we end the call, and then after the call, we um, book the reservation because we actually do a retranscription with a better transcription model for the email address. Because some transcription models are better for live AI voice agents. They're very good at streaming, they're low latency, but they're less accurate compared to higher accuracy, slow transcription models that can be used post call to improve the accuracy. So basically, what I'm trying to say is next, I did a bunch of tests on different transcription models and their accuracy. And for these tests, I used Gemini 2.0 Flash throughout, same prompt throughout. So the only difference is the transcription model. Again, we have the simple versus complex. I'm going to speak about that in a second. And as you can see, our highest performing for simple was Whisper. You can ignore Scribe being 0 for a second. As I was doing these tests, I had already done these tests for like over a week, and then Scribe released, or 11 Labs, sorry, released Scribe speech to text. And so I kind of did it, but I only did it for complex. So it's a 0 on simple, but you'll see the complex accuracy in a second. As you can see, yeah, Whisper from OpenAI was the highest accuracy in terms of, pure inbound accuracy. I'm going to quickly mention actually how I got the test data set. For this, what I did was I actually, created 10 unique example emails, which were actually pretty difficult, i.e. they had underscores, they had numbers, they had dots. And as you can see, yeah, from this data set, we got Whisper having 67% accuracy on the simple, 44 from Gladia. Gladia actually, I believe, is using also Whisper fine-tuned under the hood, but yeah, it got a little bit worse accuracy. Nova 2 versus Nova 3, as you can see, it wasn't that big of a difference in this inbound scenario. Speechmatics, it just did terrible. I don't know what happened with Speechmatics, and Assembly AI, not the best either. But with complex accuracy, I was able to increase this accuracy for all of them overall by quite a little bit. As you can see, Scribe did the best. So yeah, the newer model did the best, which is good. You can see that didn't actually happen with Nova 3. I wonder why. I think Nova 3 is better with overall transcription than DeepGram Nova 2. It does actually seem that way, but maybe not the best for transcribing email address things like people saying underscore or dot or those types of things. So yeah, as you can see, we got 89, 84, 76, and something I want to mention is, like I said, we were using Gemini 2.0 Flash to extract the emails from the transcripts we got in the test data set. And again, for this, we did 50 transcription runs per test data set. So I did, 5,000 plus runs. I spent a lot of money this video basically to test and actually get some proper data for myself and for you guys. Now, something I do want to mention, like I just said, and I rambled, is that with Gemini 2.0 Flash, this is the accuracy we got. But when I used O1, which you saw wasn't in the data set for the models, the reason why I didn't test O1 is just because it's expensive. I didn't want to spend that much money, and running O1 500 times would be expensive. It would also take a long time because I was running this all on my laptop. And yeah, I just kind of passed it and just use R1 instead. But when I was using DeepSeek, I mean, sorry, not DeepSeek, O1, just the normal version on reasoning effort medium or high, it was actually able to make the scribe transcription 100%. So it got everything accurate, meaning that the transcription model, that being scribe, did it perfect. The only issue was the model losing some of Scribe's accuracy. So that was amazing, right? If you use the best speech to text model and the best LLM model to reason about what the email is, we are able to make the accuracy 100%. And when I also tested this with Whisper, because I only tested the O1 for Whisper and Scribe, because, these are the two highest numbers by quite a bit, 84 and 76 is quite a big difference. I got this up to like 92%, I believe. So again, it also really helped with the overall extraction of emails. So let's talk about what the complex accuracy meant. What was the switch between simple, which got me, 67 at the highest, 44 second, to 89, 84, and 76. Like that top three, again, is a massive, massive difference. And technically, really, 192 if we really put all the money and effort into this extraction of emails. In order to do this, it is so, so, so simple. I just got the AI to confirm the person's email. I basically wanted the AI because sometimes when the person says something on the phone, the transcription model on the phone is going to hear it differently. And then if we don't get the AI to confirm, we're going to lose out on some of that accuracy. So literally that big of a difference was just getting the LLM to basically be like, oh, did you say John.Green at whatevercompany.com, or did you say john.green77 at whatevercompany.com? Like, what exactly did you say, basically? And the person will, say it one more time or spell it out, or the AI says like, oh, how do you spell John? Because, or how do you spell that company name? Because I'm not too sure. And the person spells it out letter by letter. That makes it really, really easy for a really good model, transcription and LLM, to basically be like, okay, yeah, the email is more than likely going to be this. So those were the experiments I ran. As you can see in my small little test and small little experiments, I was able to achieve really 100% accuracy if I were to use O1 high or O1 with reasoning effort high. But yeah, I would say 99%, because obviously there's some issues in my test data. It's not going to be perfect. It's a pretty small scale experiment. It's not done on hundreds of thousands of runs or hundreds of thousands of different generations. It was just, the small lower end of thousands. Maybe I think I did 5,000 runs of the transcript and 5,000 runs of all the different LLMs. So yeah, a pretty small experiment, but I would say my accuracy ended up at around 99% overall on average. Now, the only caveat for some of the stuff, and some of the stuff I want to talk about, is that some of the things that we're doing has to be on the call, right? Like, let's say we're looking up someone's order status, and to look up their order status, we're not using their order ID, we're using their email, let's say. And for that, we need to get their email, and we need the agent to get it right on the call, and then use the, get order status or whatever tool we're using, get back the result, and then let them know what their order status was. So for this, we need to get the email correct on the call. Now, to improve the accuracy of that, I mean, we can do what we did with the inbound and, get them to confirm, and, that way we can improve the accuracy of that. Also, what we could do is in the tool call, if we don't find an email that matches, we can let them know, or let the person on the other side of the phone say, I tried to find your order status based on this email, let's say john.doe@gmail.com, but I couldn't find anything. Am I 100% sure I'm spelling it correctly? Oh, no, actually, it's John_Doe, let's say. Oh, perfect. Okay, let me check again. This time it's correct. Okay, cool. With that kind of conversation, you can be a bit more conversational, be like, I might have misspelled it. Can you confirm one more time, please? Sorry. And you can, in the end, you will more than likely get the email correct. But with some of the stuff like booking stuff, where there's no right or wrong email in a sense, right? If you're booking a reservation, when you book the reservation, it's going to take any email. It's not going to be like, oh, this is the wrong email, in terms of sending the booking to the API. It's not going to be like, oh, this email isn't a thing. You might have the wrong email in terms of what the person said, but it's still an email, and it's going to take that, but it's going to be wrong in the overarching thing of the person, of what they said. I don't know how to explain that. Basically, you can get the email right and wrong at the same time. And so for that, we need 100% accuracy, because we're not going to get a response saying that's the wrong email. Can you do it again? Or ask them again, because there's no right or wrong email in terms of sending it to the API, because you can use any email to send to a book reservation. So that's why we need 100% accuracy. So for those instances where we don't need to, we don't need to get any response back, we just need to send something, we can just do it post call, grab the recording from the call. Like, let's say we trigger a scenario where if someone, was supposed to book a call or book a reservation during that conversation with the agent, we create some sort of trigger with a scenario that runs and retranscribes the call with one of those better transcription models like Scribe from 11 Labs or Whisper from OpenAI. And we use one of the better O1 models to simply extract the email just from the transcript. And then, we use that email to book the reservation post call. This is fine. There's no reason why we have to book the reservation on the call. We can do it after. As long as, if we know there's availability, there's not going to be any issues with the booking of the reservation. So we are able to do that after, and, really improve the accuracy in that way. So yeah, hopefully you've learned something in terms of improving email extraction accuracy. Yeah, let me know if you have any questions, like for your specific use case. How would I go about improving, that use case or that scenario, those types of things. Just give me your scenario, give me your problem to do with email extraction in the comments. If this video hasn't helped in any way, then I will do my best to go through the comments and explain to you how I would go about improving the extraction of the email.